Hello everyone, welcome to Mastermind. Today let us learn about nuclear fusion in this video. First of all, let us see the definition of nuclear fusion. Nuclear fusion is defined as the combining, please remember this is a keyword, combining of several small nuclei, to form a large nucleus with the subsequent release of huge amounts of energy. Let us take the example of deuterium and tritium in this figure. Deuterium and tritium are getting fused together to release large amount of energy to form helium, which is a large nucleus. When compared with deuterium and tritium, helium is a large nucleus, and this represents a nuclear fusion reaction. Usually, nuclear fusion reaction happens in sun and other cosmic bodies. Nuclear fusion powers our sun, and harnessing this fusion energy could provide an unlimited amount of renewable energy. It provides unlimited amount of renewable energy. In the sun, the extreme pressure produced by its immense gravity creates the conditions for fusion to happen. In order for a fusion to take place, there must be extreme pressure. This particular condition is provided in the sun due to its immense gravity, whereas realizing this type of conditions on Earth is very difficult. This fusion reaction is an opposite reaction of fission. Fission is the opposite reaction of nuclear fusion. What happens in a fission reaction? A heavy nucleus is split into two or more small nuclei, and fission reaction doesn't require extreme temperature and pressure conditions for the reaction to sustain. Whereas when it comes to nuclear fusion, it requires tremendous amount of pressure for the reaction to sustain. The process of fusion releases energy because the total mass of the resulting single nucleus is less than the mass of the two original nuclei. If you look at this example over here, deuterium and tritium combinedly have greater mass in comparison to helium. So this difference in mass gets released as energy. This particular leftover mass becomes energy, and this also satisfies Einstein's equations E equals mc square. Please remember this is Einstein's energy mass relation, E equals mc square, which says in part that mass and energy can be converted into each other. So here when you look at the difference in mass getting converted into energy, E equals mc square gets applied to this particular fusion reaction. And moreover, fusion reaction gives out more energy in comparison to fission reaction. As I have already told you, fission reaction is a reaction in which a heavy nucleus gets split up into two or more smaller nuclei. So if the scientists develop a way to harness this energy from fusion in machines on Earth, it could be an important method of energy production on Earth. It could be an important method for energy production for Earth. Fusion reaction takes place in a state of matter called plasma. Plasma, this is a keyword, please remember. Plasma is a hot charged gas made of positive ions. It is made of positive ions and free moving electrons that has unique properties distinct from solids, liquids and gases. This is actually fourth matter. Plasma is actually considered as fourth state of matter. Please remember this, it is considered as fourth state of matter. At high temperatures, electrons are ripped from atoms' nuclei and become a plasma. When electrons get ripped from atoms' nuclei, when atom consists of both protons and neutrons, at high pressure or at high temperature, what happens is this electron gets discharged from the atom and they start moving as the free electrons, and this gives rise to plasma. So plasma is the fourth state of matter, and when at high temperatures electrons get ripped from atoms nuclei, they become plasma or an ionized state of matter. It is also called as ionized state of matter. Fusion can involve many different elements in the periodic table. Not necessarily it has to happen between deuterium and tritium. It can happen between various elements as we have seen. But researchers working on fusion energy applications in the present are especially interested in this reaction, which is the deuterium and tritium reaction. So deuterium tritium fusion is being worked upon now. Deuterium tritium fusion produces a neutron. See, this is the neutron over here. It produces a neutron and helium nucleus. In the process, it also releases much more energy than most fusion reaction occurs. This particular fusion reaction gives out more energy in comparison to other nuclear reaction which involves other elements. So scientists are more interested in deuterium-tritium fusion reaction. In a potential future fusion power plants such as tokamak or stellarator, I will be speaking about tokamak in few minutes. When this particular fusion happens in a tokamak or stellarator, neutrons from deuterium reactions would generate power for use. This neutron could be used for the power generations. Researchers are focusing on DT reactions both because they produce large amounts of energy and they occur at low temperatures than other elements. This is very, very important. Usually for a nuclear fusion to sustain, high temperature is required, especially when the nuclear fusion involves other elements. But whereas when the nuclear fusion involves deuterium and tritium, reaction could be sustained even at lower temperatures, not necessarily very low, but lower temperatures in comparison to other nuclear reactions involving other chemical elements. So this is all about nuclear fusion. Now let us see the tokamak or International Thermonuclear Experimental Reactor. Now let us focus on International Thermonuclear Experimental Reactor or ITER. ITER. ITER means the way in Latin. ITER means it is the way. The meaning of ITER is the way in Latin. It is one of the most ambitious energy products in the world as of today. The ITER project is a globe-spanning collaboration of 35 nations. It is located in France. It is a collaboration of 35 nations and presently it is in France. It was launched in the year 1985. It was launched in the year 1985 as a collaboration between 35 nations and it is located in France. The ITER members are China, remember this. The ITER members China, European Union, India, Japan, Korea, Russia, United States of America have combined resources to conquer one of the greatest frontiers in science, reproducing on Earth the boundless energy that fuels the sun and the stars. Which is it? It is the nuclear fusion. As we have already discussed, this reaction is the nuclear fusion. So ITR will be the first fusion device to produce net energy. What is the meaning of net energy? The energy difference will be there and the energy produced will be greater than the energy consumed to sustain the reaction. So ITER will be the first fusion device to produce net energy and it will also be the first fusion device to maintain fusion for a long period of time. It will also be the first device to maintain fusion for long periods of time. This is also very important. You will have to remember this. It will be the first device to maintain fusion for long periods of time. And along with this, it will also be the first fusion device to test the integrated technologies, materials, and physics regimes necessary for the commercial production of fusion-based electricity. India became a full seventh partner of ITER in December 2005. In December 2005, India became a full partner or India became the seventh partner of ITER. ITER India. ITER India. You will have to remember this. This Institute of Plasma Research located in Gandhinagar, Western India is the Indian domestic agency to design, build and deliver the Indian in-kind contribution to ITER. ITER's first plasma, that is the reaction is going to begin in the year December 2025. December 2025. The first reaction or the first plasma is scheduled. That will be the first time the machine is powered on and the first act of ITER's multi-decade operational program. As we have seen, this began in the year 1985 and it is going to happen in the year 2025. It is necessarily a multi-decadal program. It has got through many decades as of now. So the ITER's first plasma is scheduled for December 2025. Now let us look at the device used in this particular project, which is called as tokamak. Tokamak is an experimental machine. It is an experimental machine designed to harness the energy that is generated from the fusion reaction. So, inside a tokamak, the energy produced through the fusion of atoms is absorbed as heat. The energy that is produced is absorbed as heat in the walls of the vessels, and just like any other conventional power plant, a fusion power plant will also use this heat to produce steam, and through this steam the electricity is generated by way of turbines and generators. Tokamak was first developed by Soviet research in the late 1960s. This particular device to sustain fusion reaction was developed in late 1960s. The tokamak has been adopted around the world as the most promising configuration of magnetic fusion device. It is regarded as the most promising configuration of magnetic fusion device. ITER, that is the International Thermonuclear Experimental Reactor, will be the world's largest tokamak, twice the size of the largest machine currently in operation, with 10 times the plasma chamber volume. So ITER will entail world's largest tokamak, which is twice the size of the largest machine currently in operation. Now let us see what will ITER do. First of all, ITER aims to produce 500 megawatts of fusion power. Next is it demonstrates the integrated operation of technologies required for a fusion power plant. So it is going to demonstrate the integrated operation of technologies for a fusion power plant. Next, it is going to achieve a deuterium-tritium plasma in which the reaction is sustained through the internal heating. So it is going to achieve a deuterium-tritium plasma. Next is it is going to test tritium breeding, which is another important feature of ITER. Lastly, it is going to demonstrate the safety characteristics of a fusion device. So it is going to learn what are the safety characteristics required for future fusion power plants. So this is all we have for you in this video. Please go through the video multiple times and also refer to the article as well. Thank you.